All right, we are now going to do some analysis of these three linear functions that we came up with. The first one was f of x equals negative 2/3 x minus 2. So let's think about this for just a moment. We're going to answer some questions about this. Based on the values of a and b, through which quadrant will the graph of f of x not pass? So this is going back up to what we said earlier. So in this case, our a is positive. So let's just make a note of that. A is positive and b is negative. So if a is positive and b is negative, we can look through it, we can think through it, we can draw a quick picture. But it looks like if a is positive and b is negative, this will not go through quadrant 2. All right, so when we graph it, it should not pass through quadrant 2. All right, let's see if we're right. Okay, so we're going to use the equation for f of x to compute some values over here. All right, and this is then use the ordered pairs to graph the linear function on the grid to the right. But I'm going to back us up a little bit. We can use those ordered pairs to graph it, or we can use the slope and the y-intercept. We're going to start off by doing it with the ordered pairs, and then at the end I'll show you how I would do it probably faster. But they both work, all right? Okay, so we're going to plug in different values of x into f of x and get a y value, all right? So if we want x to be negative 6, we're going to plug that in to figure out what our y is. So a function always is going to generate y values for you. Whatever you plug in for x, you get an answer. What's your input? So our input here is negative 6. So we're going to take our function, which is 2/3 times x, and our x is a negative 6, and we're going to subtract 2. All right, we should be able to do this without a calculator. So let's think for just a moment. What is 2 times negative 6? That should be negative 12. And then this means divided by 3. 2 times negative 6 divided by 3. That's all a fraction is. You're multiplying by the top and dividing by the bottom. All right, so 2 times negative 6 is negative 12. Negative 12 divided by 3 is negative 4. So we've got negative 4 minus 2, which is negative 6. So when we have x equals negative 6, y equals negative 6, and our ordered pair is negative 6, negative 6. Okay. All right, then we're going to do 2/3 times negative 3 minus 2. 2 times negative 3 is negative 6, divided by 3 is negative 2, minus 2, negative 4. So when I have a negative 3 for x, I get a negative 4 for y. Keep going, just plugging in your answers. I'm not going to explain every bit of math. Y'all should be able to figure that out. This is 0. And then we have 2/3 times 6 minus 2. That's 4 minus 2, which is 2. All right, so we now should be able to graph these ordered pairs. Negative 6, negative 6, negative 3, negative 4, 0, negative 2, 3, 0, 6, 2. And now we connect them because this is a linear function. It's not just those pairs. It's all the pairs in between them. And the idea is that any point, if we go to any point on this graph anywhere, forever and ever 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 and always, the relationship between x and y is explained by this. If I go here and I take that x value and I multiply by 2/3 and I subtract 2, I should end up with the y value of that coordinate. All right, now that is one way to graph a function every time. Just pick some values for x, plug them in, get some ordered pairs. We know this is a linear function, so we could use the y-intercept and the slope to graph it. If we did it that way, we would use a y-intercept of negative 2, and then we would do a slope of 2/3, which means we're going to rise 2, run 3. So if I go to negative 2 on the y-axis, there's my y-intercept, and I would put a point there. And I'm going to go up 2, right 3 to get to another point, up 2, right 3 to get to another point. You don't have to do them all. If you connect them, it should still go through them that way. All right. Now this says to investigate the graph. So we are going to look at the graph of f of x, which we've already done. So from the graph, okay, I'm going to reiterate that. From the graph, identify the indicated values of x for the function. So this wants to know, identify the values where f of x is equal to 0. Well, we know how to do that. Where is f of x equal to 0? That means y equals 0. That's right here. So that's going to be at x equals 3. Okay? Then it wants to know, when is f of x less than 0? So remember, less than 0 means below x-axis. When is it negative? So it's below the x-axis this way, from negative infinity until we get to 3. Not at 3, because at 3 it actually equals 0. So it's below the x-axis from negative infinity to 3, and it's above the x-axis from 3 forever. All right, so we know how to look at that from the graph. Now we're going to talk about doing it analytically, using the equation. So not the graph, but the equation. But our answers should match. From the equation means we're doing it analytically or algebraically. Okay, so we want to know where f of x equals 0. Well, we know that f of x equals 2/3 x minus 2. So we need to know where 2/3 times x minus 2, when does that equal 0? All right? Okay, let's solve that equation. That's going to be 2/3 x equals 2, because we're going to add 2 to both sides. And then the way we get rid of 2/3 as a fraction is we multiply by the reciprocal. Over here on the left, multiplying by the reciprocal, this equals 1. 6/6, or they cancel, and you're left with x. And over here, I've got 2 times 3, which is 6 divided by 2, which is 3, right? Notice I have the same answer as I got previously. Whoops, let me back up. This says that according to the equation, the function equals 0 when x equals 3. The graph said the same thing. So the equations in the graph say the exact same thing. All right, identify the interval along the x-axis where f of x is less than 0. All right, we're going to solve the equation the same way. 2/3 x minus 2 is less than 0. 2/3 x has to be less than 2. We multiply both sides. We get x has to be less than 3. Okay, the way we write that as an interval, right, agreed, is we say x is less than 3, or we say x is from negative infinity to 3. Same interval as we got before, and then we'll repeat the process here. 2/3 x minus 2. When is it greater than 0? So x is going to be, has to be greater than 3. It matches our answers above. So now we're starting to, we've done a lot of work with looking at tables of values and with looking at graphs. So here we have a numerical representation of f of x, we have a graphical representation of f of x, and we have an algebraic representation of f of x. And they all three say the same thing.